What scientists found beneath your feet was something they never expected to find. And when they found it, they couldn't believe it. In the heart of Wyoming, there's a national park known for its geysers, its colorful hot springs, and the herds of bison that wander across the roads like they own the place. Yellowstone. Millions of people visit every single year. Kids run the trails, families snap photos at bubbling thermal pools, couples watch Old Faithful shoot water over 150 feet into the air. But what almost none of those visitors know, and what scientists themselves only recently understood in its full scale, is that Yellowstone is one of the most dangerous and most fascinating volcanic systems on the entire planet. We're not talking about a regular volcano here. There's no mountain with a crater on top. What's underneath Yellowstone is something completely different, a structure so massive that for decades, geologists simply couldn't see it clearly enough to understand what they were looking at. That changed in 2015, when a team of researchers at the University of Utah used advanced seismic imaging technology to map the park's underground with a precision that had never been achieved before. And what they found sent shockwaves through the scientific community. Imagine being able to take a giant X-ray of the ground beneath Yellowstone. That's essentially what these researchers did, using seismic waves to pierce through the rock and build three-dimensional images of the deep layers underneath. What appeared on their computer screens was deeply unsettling. Beneath the park, there isn't one magma chamber, there are two. Two enormous pockets of molten rock trapped beneath a relatively thin crust. The upper chamber, which scientists had already suspected existed, turned out to be far larger than any previous estimate had suggested. It stretches roughly 55 miles long, about 18 miles wide, and reaches nearly 10 miles deep. To give you a sense of the scale, that chamber alone is large enough to hold the entire volume of water in the Great Salt Lake, one of the biggest lakes in the United States. But the real surprise was even deeper. Scientists discovered a second chamber, even larger, sitting between 12 and 30 miles beneath the surface. This lower chamber holds 4.4 times more magma than the upper one. In concrete terms, we're talking about a reservoir of molten rock large enough to fill the Grand Canyon more than 11 times over. 11 times the Grand Canyon. Full of magma. Beneath your feet. When researchers published these findings in the journal Science, the reaction was immediate. Headlines ran in newspapers around the world. TV programs dedicated hours to the story. And one question started haunting geologists, volcanologists, and government officials alike. When is this thing going to blow again? To understand why this discovery hit so hard, you have to go back in time, way before the United States existed as a nation, before any recorded human history in the region. Yellowstone has erupted 3 times in its recent geological history. And when I say recently in geological terms, we're talking about timescales the human mind can barely wrap itself around. The first major eruption happened roughly 2.1 million years ago. The second, about 1.3 million years ago. The third and most recent one, at least the most recent one scientists have been able to document, occurred 640,000 years ago. Each of those eruptions was what's called a supereruption. That term has a very specific technical meaning in volcanology. It refers to an eruption that ejects more than 1,000 cubic kilometers of material. To put that in perspective, the famous eruption of Mount St. Helens in Washington state in 1980, which killed 57 people and flattened the forest for miles in every direction, ejected roughly 1 cubic kilometer of material. Yellowstone's last supereruption ejected more than 1,000 times that amount. The volcanic ash from that eruption, 640,000 years ago, blanketed much of what is now the central and western United States. The cloud of material thrown into the atmosphere would have blocked sunlight for years, triggering what scientists call a volcanic winter, capable of altering the climate of the entire planet. Now add that information to what scientists just discovered about the true size of the magma system beneath the park. The equation starts getting very, very interesting. But the surprises didn't stop with the discovery of 2 magma chambers. The more researchers analyzed the seismic data, the more complex the picture became. They found that Yellowstone isn't simply an isolated pocket of magma sitting there waiting to explode. It's an incredibly dynamic system, connected to an even deeper heat source, a mantle plume, essentially a chimney of superheated rock rising from deep within Earth's mantle all the way to the surface. That plume has existed for at least 17 million years. And the North American plate has been slowly drifting over it the entire time. That's why there's a chain of ancient volcanic calderas running across the state of Idaho toward Wyoming, like a trail of geological scars marking the path the continent has traveled over this hot spot. Yellowstone is the most recent stop on that trail, and the system is still very much alive. Researchers also identified something they called a magma sponge, a partially molten zone connecting the two chambers, acting as a kind of transition chamber. This zone is key to understanding how magma can move from one reservoir to the other and eventually reach the surface. What makes all of this even more unsettling is the speed at which some changes happen. In certain areas of the park, the ground literally rises and falls like a chest breathing, a phenomenon called ground deformation. In some years, parts of the park have risen more than 8 inches in just a few months. In other periods, they've dropped back down. Scientists track these movements using high-precision GPS, accelerometers, and a network of seismographs spread throughout the park. That data flows in real time to labs across the country. Yellowstone is one of the most seismically active places in the entire United States. We're not talking about major earthquakes, those are rare. We're talking about a constant, relentless low-level seismic activity humming away beneath the surface. The park records between 1,500 and 3,000 earthquakes every year. Most are so small that visitors never feel a thing. But periodically, something called a seismic swarm rolls through, sequences of hundreds or even thousands of earthquakes packed into just a few days. In December 2008 and January 2009, a swarm lasted nearly 2 weeks and included over 900 individual earthquakes. In 2010, another swarm produced more than 2,000 tremors in just 10 days. In 2017, a sequence of nearly 2,400 earthquakes stretched out over 3 months, the largest swarm ever recorded in the modern monitoring history of the park. Every time one of these swarms hits, the internet goes into full meltdown mode. Alarming headlines pop up on sites around the world. People actually call the park asking if they should evacuate. The official response from the U.S. Geological Survey, the USGS, which monitors Yellowstone, is always the same: relax. Seismic swarms are normal for an active volcanic system. They usually reflect the movement of hydrothermal fluids and small fractures in the rock, not necessarily magma pushing toward the surface. But scientists are also honest about what they don't know. And what they don't know is still a lot. What the 2015 magma chamber discovery made clear, above all else, is that Yellowstone is even more complex than any previous model had predicted. And complex systems, by the very nature of complexity, are harder to predict. This is the question everyone wants to ask, but almost nobody wants to hear the answer to. Scientists have run the simulations, and the results are, to put it mildly, grim. A Yellowstone supereruption would hurl billions of tons of volcanic ash into the atmosphere. The closest states, Wyoming, Montana, Idaho, would be buried under layers of ash several feet thick. Cities like Denver, Salt Lake City, and Cheyenne would be covered in meters of volcanic material. But the impact wouldn't stay in the American West. The ash cloud, carried by high-altitude winds, would spread across the entire continental United States within days. The East Coast would be hit within weeks. Europe, Asia, South America, all would receive volcanic particles in their atmosphere within months. And here's the scariest part: volcanic ash in the atmosphere reflects sunlight back into space. That cools the planet. Climate models suggest a Yellowstone supereruption could drop the average global temperature by several degrees for years, possibly for a decade or more. A temperature drop like that would be enough to collapse agriculture across much of the northern hemisphere. Crops would fail. Livestock would die. The global food chain would be shaken in ways no living generation has ever experienced. Economists who tried to model the financial impact stopped publishing their numbers because the estimates got so large they seemed unbelievable. We're talking about an event that could cost tens of trillions of dollars, a figure that surpasses the GDP of several of the world's largest economies combined. But, and this but is really important, the very scientists running these simulations are the first to tell you that the odds of Yellowstone hitting a supereruption in the next few centuries are extremely low. The USGS estimates the probability of a Yellowstone supereruption in any given century at roughly 0.00014%. To put that in perspective, you are far more likely to be struck by a meteorite. But that doesn't mean Yellowstone is harmless. Scientists draw a clear line between supereruptions and smaller eruptions, and the smaller ones are far more likely. The most recent eruption at Yellowstone wasn't the 640,000-year-old supereruption. It was a lava flow, much smaller, but still significant, that happened just 70,000 years ago. And hydrothermal eruptions, caused by water heated by magma turning to steam, happen far more often than most people realize. In 1989, an unexpected hydrothermal eruption created a new crater inside the park. In 2003, an area called Biscuit Basin went through a series of hydrothermal explosions that sent rock fragments flying dozens of meters. Hydrothermal eruptions aren't super eruptions. They're not going to destroy the planet. But they're a constant reminder that Yellowstone is a living, active, always moving system. And that's exactly why the US government pours millions of dollars a year into monitoring it. The Yellowstone Volcano Observatory, run by the USGS, operates around the clock, 7 days a week, collecting data from dozens of instruments. Any significant shift in seismic activity, ground deformation, or thermal spring temperatures is analyzed immediately. The logic is simple. The better you understand a system, the sooner you can notice when something's changing. And the sooner you notice, the more time you have to make decisions. But Yellowstone isn't just a potential threat. It's also one of the most fascinating and biologically rich environments science has ever studied. The park's thermal springs, heated by the same magma that haunts the risk models, are home to life forms that literally don't exist anywhere else on Earth. Organisms called extremophiles, creatures that thrive in conditions that would kill anything else, were discovered in these waters back in the 1960s and 70s. One of those discoveries changed the entire history of molecular biology. In 1966, a microbiologist named Thomas Brock was studying Yellowstone's thermal springs when he discovered bacteria living comfortably in water at around 160 degrees Fahrenheit. That was considered impossible by the science of the day. Bacteria at 160 degrees? Can't happen. Life would denature. But there they were, alive, multiplying, thriving. Brock collected samples and took them back to his lab. Years later, other scientists isolated an enzyme produced by those bacteria, an enzyme that functions at extremely high temperatures without breaking down. That enzyme was named Taq polymerase. If you've never heard of it, that's fine. But you definitely know what it made possible. PCR, polymerase chain reaction. The DNA amplification technique that became the foundation of all modern molecular biology. The same technique used in paternity tests, criminal investigations, disease diagnostics, vaccine development, and, most recently, in the COVID-19 tests that billions of people took during the pandemic. All of that because one scientist found a strange little bacterium in a Yellowstone hot spring. That is the power of what lives beneath that volcano. The 2015 discovery opened a new era of Yellowstone research. But it also revealed just how much we still don't know. One of the most pressing questions researchers are trying to answer is, what's the exact ratio of fully liquid magma inside those chambers? Because the chambers aren't simply pools of completely melted rock. They're complex mixtures of solid rock, partially melted rock, and fluids. The ratio between those components is critical for predicting how the system might behave in the future. Right now, scientists estimate that Yellowstone's upper chamber contains somewhere between 5 and 15% fully liquid magma. The lower chamber may hold between 2 and 5%. Those percentages are considered relatively low, which is one of the main reasons scientists don't believe a supereruption is imminent. But there's another project underway that could completely reshape our understanding of the system. The EarthScope Transportable Array. This initiative, coordinated by the National Science Foundation, installed hundreds of portable seismometers across the entire country, creating the largest seismic monitoring network in American history. The data being collected by that network is allowing scientists to build even more detailed images of Yellowstone's interior and of the entire geological structure of the United States, down hundreds of miles. What's showing up in those deeper images is, once again, surprising. The mantle plume feeding Yellowstone appears to tilt significantly as it descends toward the lower mantle. And there are signs of ancient geological structures, buried at great depth, that scientists are still trying to make sense of. Beneath America, there is a world that humanity is only just beginning to see. There's something deeply human about the way we respond to Yellowstone. On one side, there's fear. The possibility of a planet-scale catastrophe lurking beneath a place that looks so beautiful, so peaceful, so safe, with bison grazing calmly while tourists eat ice cream, touches something very primal in us. On the other side, there's wonder. The science that came out of studying this geological system has contributed to some of the greatest achievements in modern medicine. The creatures living in those impossible thermal springs expanded what we thought was possible for life itself. The seismic images showing the interior of our planet are, in their own way, just as awe-inspiring as photographs from deep space. And maybe the most important thing Yellowstone reminds us of is this: we live on a living planet. Earth is not a static stage where the human story plays out. It is a dynamic, constantly transforming system with its own agenda, one that doesn't check our calendars. The solid ground beneath our feet is, on a geological scale, temporary. Continents drift. Oceans open and close. Mountains rise and are worn down to nothing. And beneath one of the most visited places on Earth, a park that welcomes 4 million tourists every year, sits one of the largest reservoirs of molten rock ever mapped by science. That's not a reason to panic. It's a reason for humility and for curiosity, because every answer scientists find about Yellowstone opens a window onto new questions. And that is exactly how human knowledge works, not as a straight line toward certainty, but as an ever-expanding spiral, revealing worlds within worlds, mysteries within mysteries. So, what was found beneath this volcano? 2 magma reservoirs of colossal scale, larger than any previous estimate. A heat plume rising from Earth's mantle that has existed for 17 million years. Bacteria living where life has no business surviving. Bacteria that sparked one of the greatest technological revolutions in the history of medicine. A seismic system that never stops, that breathes, that shifts, that transforms, day after day, while millions of people walk right over it without any idea what's beneath them. Yellowstone is not just a national park. It is a window into the interior of our planet. And every time scientists crack that window open a little further, what they see on the other side is more astonishing and more humbling than they expected. If you made it this far, you now know more about what lies beneath Yellowstone than the vast majority of people who have actually stood inside the park. That is the power of science. And that power, thankfully, has no bottom.